Hello, this is SND College of Engineering and Research Center, Yeola, lecture series for first year engineering. I am Chaudhary Vivek Sitaram from first year department. Today's topic is about lasers, that is from the second unit, lasers and optic fiber. So as we know, history of the lasers were invented by Charles Towns and Arthur Schawlow of Bell Laboratories, which was based on the Einstein's. And in day-to-day life, we have been utilizing laser printer as well as laser pointers. Now, what is laser? The laser is an acronym for the light amplification by stimulated emission of radiation. It is a device which produces a coherent beam of optical radiation. Now, what is the properties of lasers? In lasers, we are having the monochromatic, it is directional and coherent. Now, what do you mean by monochromatic? Mono means one and chromatic means wavelength. It is having only one wavelength. But if we compare to as other sources of light, they are having many wavelengths in one light source. But in laser, we are having only one wavelength. That's why it is a monochromatic. Now, second property is about the directional. The laser lights are parallel to each other, generated parallel to each other in lasers itself also. And that's why these are directional. They are not spread out in a large area. And the last property is about third important property, the laser light is coherent. Coherent means whatever may be the light coming out from the light source, that is from the laser light source, all are in phase. The phase difference between the all rays of the laser is 0 degree. That's why these are the main three properties of the lasers, that is monochromatic, directional and coherent. These properties of lasers make it hazardous than ordinary light. Now, when we are observing monochromaticity, in helium neon laser, if we observe the example, the nearly monochromatic means there are some wavelengths are present, but which are 0.2 nanometer of difference. And in helium neon laser, it is operated at 632.5 nanometer. And if we compared the directionality, here the beam divergence of the bulb is considered as in the left side figure. The whatever may be the beam are spread up of the bulb all over the directional. That's why if its power is considered 100 watt, the 100 watt is considered throughout the sphere of the bulb. But if we consider the laser light, which is of 1 millimeter beam width, then its maximum intensity is spread only in 1 millimeter. That's why it is hazardous. And the divergence angle is very, very less. Now about the coherence. If we see the left side figure, the different rays of the light, different colors, having the different frequencies, and so as the different, if their starting angle, the phase difference, though starting phase difference is 0, but due to the frequency, there is a phase difference. But if we consider the coherent light, that is light output from the laser in the left side figure, all the rays are in phase, all the frequency, it is monochromatic. That's why the frequency is same, wavelength is same. So the wave difference is also same, and there is a 0 difference. That's why it is called as a coherence. Now, if we consider the incandescent bulb, so incandescent bulb and laser light, if we consider the small comparison, then what happens? The incandescent bulb having the many wavelengths. It is multidirectional, it is incoherent. But as compared to this, laser is monochromatic, directional and coherent. Basic concept for laser. So laser mechanism, which we call the basic concept of laser, in this there is absorption, spontaneous emission, stimulated emission and population inversion. So whenever we are giving the energy to the atoms of the laser constituent material, then what happens? The outermost energy, the electrons in the outermost energy level absorb this energy, and this energy may be in the form of thermal energy, electrical energy, or optical energy. The energy is absorbed by the outermost orbit electrons, and then they are excited into the higher energy level. Here in the figure, energy of an electron in the E1 state, the energy we are allowed here, photon energy, h nu, is allowed to on this electron. Then that electron transit from ground state, E1 state, to E2 state. That is, electron is excited. Okay. Now, when that electron jumps from a higher energy level to the lower energy level after its lifetime, then that time the energy, absorbed energy, get emitted out, and that is called as the spontaneous emission. The direction of this spontaneous ray is random in direction, and this is random process. Okay. Now, what is stimulated emission? When we are giving external energy to the excited electron in the E2 level, then that photon, incident photon, purposely stimulate the higher energy level to the lower energy level, and it gives out the two photons, one incident photon and one is generated photon. The importance is that both the photons having the same energy h nu, and both are having in phase, and the direction is also same. That's why this is called as a stimulated emission. Now, the characteristics of stimulated emission, or we may call unique property, that is, they are in phase, having the same wavelength and same direction. Same wavelength means same frequency. Okay. Now, what is population inversion? When we are giving external energy to the electrons, or to the electrons in the outermost orbit for a lasing action, for a lasing mechanism, that energy is get absorbed by that electrons and jumps into the higher energy level. That is called as the pumping. So the number of electrons in the lower energy level gets less amount, and the number of electrons in the higher energy level are having the higher energy. Number of electrons in the higher energy level are higher, and that's why it is called as the population inversion. The population from the lower energy level is decreased, and population into the higher energy level is increased. That's why it is called as the population inversion. And that can be occurred by optical pumping or electrical pumping, or in semiconductor there is a movement of electrons. This. Now consider a two-level system. There are in laser, there are different level systems: 2-level laser system, 3-level laser system, 4-level laser system, and so on. Now, for a basic concept, consider the 2-level laser system. In 2-level laser system, when the absorption is there, electrons from the energy level E1 absorb the incident photon energy, jumps into the higher energy level E2. Then from E2, it again jumps onto electron, excited electron, relieves out its energy in the form of photon, and it's get onto the ground level again. This is the spontaneous emission. And when spontaneous emission is allowed on an excited electron, there we will get the stimulated emission. So there is only two transition. That's why it is called as a two-level system. Now, what are the Boltzmann equations? So number of electrons at the N2 level, number of electrons in the N1 level. So N2 upon N1 is equal to E raised to minus E2 upon E1, E2 minus E1 upon KT, where N1 is the number of electrons at of the energy E1, N2 the number of electrons of energy level E2. So population inversion. Now in laser there is a resonance cavity. When spontaneous emission is there, then it generates the stimulated emission. So to achieve this stimulated emission, there is a resonance cavity, and that resonance cavity can be achieved by using two parallel mirrors. In some of the lasers, there is utilization of concentric lasers, concentric resonators, confocal resonator, hemifocal resonator, depending on the type of resonator. So conditions for the laser operation: always population at ground state level, number of electrons should be larger than the number of electrons in the higher energy level. Radiation is mostly absorbed. then we will get the spontaneous emission. Then due to in population inversion condition, number of electrons in the higher energy level, that is N2, is very very large than the N1. The most of atoms occupy level 2 and weak absorption, so there is a stimulated emission and light is amplified. So it can also be achieved by the thermal excitation. Thanks.